Hey guys, my name is Parth and I'm a rising senior at Mission San Jose High School, and this is my third and final milestone for my main project, the running glasses. So here's a quick demo/explanation. This is the GPS module I'm using, which sends data to the OLED display at a rate of every 10 seconds. So it's a refresh rate of 10 seconds, and if you want a quick demo, here's a quick inside view. The light reflects off this and then reflects off this and comes back to your eye at the same angle, or in the same plane that it bounced onto the mirror at. So in terms of how exactly this works, so I used a GPS for my project, which essentially stands for Global Positioning System, and it uses satellites in a process called trilateration. So what trilateration essentially is that it takes three satellites, right, as the name suggests, and it finds spheres of where you're probably going to be located, and it finds the intersection of these spheres, and at that location it finds the longitude and latitude where you're most likely going to be. Right. So obviously, the more satellites you have with trilateration, the more accurate your longitude and latitude are going to be, because you have a smaller space where you can probably be, or you're most likely going to be in. So for my project, I had on average about 9 to 11 satellites being connected. So for me, I think my positioning was fairly accurate, and that was sort of shown in the data I got. So in terms of how exactly I used the GPS, or how exactly I decoded it, so GPS sends you information or data in the form of NMEA sentences, and NMEA sentences are essentially data written in a pattern that you can read, and you can decrypt in order to figure out what exactly you want. Like, for example, the first part of an NMEA sentence is the number of satellites you're connected to, and another part is the longitude or the latitude that you're connected to. So if you know how these are placed and where they're placed, then you can figure out the information you want. So after I learned how they exactly work, I used a library, the tiny GPS library, to decrypt this information and make it more efficient and easier for me to use it. In the ways that I actually use this information, I used it to find the pace, the change in altitude, and the mileage. So in order to find the pace, I just used the built-in speed function. So I used the speed function and altered it by finding the reciprocal and multiplying it by 60 to find the minutes per mile, so your pace from miles per hour. And then in order to find the change in altitude, I essentially stored an initial variable, or an initial value, in a variable that represented the initial altitude that I was at, and then I updated this every 10 seconds with the new altitude that I was at, to sort of show the change in altitude and how I was running, sort of give me a more objective opinion of how fast or how hard I should run. And then the last one was the mileage. So this was probably the hardest, and what it did was it essentially this essentially just gave me the distance I ran. But the problem was that if I used I used a built-in function, which is the distance between function, and what this function does is it figures out the distance between two pairs of longitude and latitudes. So if I used the initial pair where I started at and the end pair where I ended at, that would give me a straight line, or it would tell me that I ran in a straight line, and it would give me the distance between those two. But obviously, I don't always run in a straight line, right? I probably have a few curves that I probably run in different ways, and have turns. So in order to account for that, I refreshed, or I figured out the distance for a certain small time interval that I ran, and I continued to add that to sort of represent the curve, or account for that type of change. So that was how I essentially found the mileage for this. Then in terms of what exactly I learned from this project was that, especially because if you think about it, we use GPS very often, or very often in our lives. Using it for maps, Uber, even for fitness tracking devices just like this, right? This allowed me to figure out how a GPS module works, how GPS itself works, just the general idea of a GPS, how it works with satellites, and how to create a heads-up display, essentially. So in terms of how exactly, or what challenges I faced during this project, one main challenge I faced was figuring out why my GPS wasn't working, or my distance between function wasn't working exactly how I wanted it to, right? So when I would stay at a certain spot and then walk 50 meters and stay at that spot, the difference it was giving, or the latitude and longitude positions it was giving me were the same. In order to figure this out, I had to sit back and I had to sort of think about how exactly this worked, right? How exactly NMEA sentences worked, how it gave data to the nano, and I realized that the GPS module gives the data to the nano at a certain rate, right? And the rate at which it receives information from the satellite was slower. So in order to account for that difference, it would give you this oldest possible information. So even though you would walk, it would give you the information from the last time it was updated. So in order to account for this, I used the isUpdated function, which allowed me to figure out if I had gotten a new NMEA sentence and it was actually an updated one, and I used a while loop to try to figure out until it got that new updated one, it would keep on trying to search for it. And this allowed me to make the information much more accurate and essentially allowed my project or my mileage part to work. Another problem I faced was that I placed the VCC and ground pins in the wrong places, which essentially short-circuited my GPS. So I ordered a new one, but in order to account for the time, I started building my model there, or my main framework there, which allowed me to like make up for the time I missed. So for the next few parts of this project or potential modifications, I obviously want to make this more streamlined, right, more easy to use and usable. And I also want to add a mapping function or a way to map my route. So essentially store my longitude and latitudes in an array, which I can then, after plugging in into a computer and pressing a button, which can open Google Maps and map that exact route I ran. So hope you guys enjoy this, and thanks for watching.